Space weather is the dynamic environment in space. So space is not a vacuum like many people think about it. Space is full of electromagnetic radiation, space is full of charged particles, electrons, protons, heavy ions, and this is all impacted by the sun. So sun is emitting electromagnetic radiation to all directions, as we well know, but in addition, sun is actually blasting protons, electrons, the phenomena which is called solar wind, into space to all directions. The Earth is part of space, part of the solar system, of course, and particularly when the charged particle environment changes, then the magnetic field around the Earth actually reacts to these changes. Some of these particles enter inside the magnetic field, they change the conditions inside the magnetic field, and these variations, they actually can have some quite dramatic impacts on the infrastructure that we are utilizing in our everyday life. Well, the most dramatic impact that people would immediately notice would be an impact on the power grids. So when we have an event which is called coronal mass ejection, the sun is blasting as a result of a sort of a magnetic explosion on the sun, a vast amount of plasma into space. If this plasma cloud hits the Earth, then it changes the current systems of charged particles inside the magnetic field of the Earth. And this can actually directly induce a current into our power grid. At the moment, we already have in place a system which is providing space weather information to the end users. So we help the people operating the infrastructure to prepare for a potential space weather event and try to mitigate and minimize the impacts. In the future, we want to enhance our capability. One of the the particular problems that we have today is that we cannot forecast space weather very well. What we want to do in the future is to give better forecasts, the same way as people get the meteorological forecasts for tomorrow, for 3 days, for 7 days. Long-term forecasting of space weather is difficult because sun is very difficult to predict very accurately, but at least we hope that we can give advanced warnings when something critical might be developing, and especially when there is a high risk for an extreme space weather event. In order to improve our capability to forecast space weather, we want to have actually 2 satellite systems outside the magnetic field of the Earth. One point is the L1 point, which is a first Lagrange point, the stable point between the Sun and the Earth, about 1.5 million kilometers from the Earth towards the Sun. We want to have there a spacecraft that can provide us information about the propagation of the events from the Sun towards the Earth. And then, even more importantly for the forecasting, we would like to put the spacecraft into the 5th Lagrange point, which is a point 150 million kilometers behind the Earth, on the same orbit as the Earth, and that would give us a perspective of the Sun before the surface of the Sun is visible to the Earth.
Okay, observations from multiple vantage points is of course an effort that needs to be made. And if you want to observe from different points, then you can, of course, make use of international collaborations. So one party would fly at one point, and then another party would fly the spacecraft into another point. And if we join the forces, then we can make use of all the synergies, and then it would be much more efficient to implement such a system.